Hello friends, welcome to Prismatics online class. In our today's class, we are going to look at what mathematical induction and how to solve it. In our previous class, we explained about mathematical induction, the principle of mathematical induction, the method of solving mathematical induction, and the application of what mathematical induction. But today, we are going to calculate it. We are going to solve questions on what mathematical induction. So look at the board. Let's say question 1. Using mathematical induction, prove that 1 plus 2 plus 3 plus 1 plus n equal to n into n plus 1 all over 2 for all positive integer n. All positive integer is the same thing as saying what? Natural number. They are a set of order pair. They are what? A set of order pair. You can't say 3 without counting 1. So you start from 1, 2, 3. So it is what? A set of what? Order pair. So a positive integer is the same thing as saying what? Natural number. Okay, now let's go. Solution. First, we need to show that n equal to 1 is 2. So we need to test for what? N equal to 1. So from this question, pick 1. This is first one. 1. This one, is it equal to what? N into n plus what? 1 all over what? 2. When n equal to 1. Now this one is equal to, let's check, 1 into 1 plus 1, close it all over what? 2. Now we have 1 is equals 1 into what? 1 plus 1 is 2 divided by what? 2. So this will give us that n is equal to 2 over what? 2. Hence 1 is equal, this will cancel, 1 is equal to 1. Now it is what? 2. Hence P of what? P of 1 is 2. Okay, even if you want to check this in, I want to pick 2 when n is equal to 2. That means this plus this. If I have something like when n, if you want to test another one, when n equals to 2, it means pick 2 from here, which is 1 plus 2. Is it equal to what? N into n plus 1 all over what? 2. Let's check. 1 plus this will give us 3. 3 into this. Now let's go. Anywhere we see n is equal to 2, which is 2 into 2 plus 1, close it all over what? 2. Now let's go. 3 is 3 equal to 2 into 3 all over what? 2. Now let's go. 3 is this, 2 will cancel this. 3 is equal to what? 3. So that is, it is also 2. You can see hence that P of what? P of 2 is what? True. P of 2 is what? Is what? True. So that is how to test for what? First step. That is what we call first step. It is true that any number that we pick from here, it must be equal to this side. And that is what we are doing. We want to check that whatever thing will happen that happen in left hand side must be equal to what? Right hand side. So you need to be careful with LHX is equal to RHX. The left hand side must be equal to what? The right hand side. Why proving what? Mathematical induction. Okay, now step 2. Let's show step 2. Let's show that n equals to k is true. From this place we have that 1, that is anywhere we see n, we call it k. We have what from the question? 1 plus 2 plus 3 plus plus what? N is equals to n into n plus 1 all over what? 2. Now they say when n equals to 2k, now we substitute. We have 1 plus 2 plus 3 plus plus, anyway you see n, change it to what? K. Plus is equal to what? K into what? K plus what? 1 all over what? 2. You should not expand it, but if you like, expand, but you should not expand it. It means that everything here is equal to this. So be careful with this. You can call this in equation X. Be careful with it. Okay. Now finally, let's show that P that N is equal to what? K plus 1. If N is equal to K plus 1, from this place, we now have that this is 1 plus 2 plus 3 plus plus K plus that of N, which is K plus 1, which is K plus 1. Okay, is it equal to what? Anywhere you see K, call it K plus 1. K plus 1, close it, into what? K plus 1, which is this K plus what? 1, which is this one. Close it, all over what? 2. Okay, and that is what we are going to do now. So now, what are we doing? We want to check when we pick this left hand side, if after resolving the left hand side, will it give us equal to the right hand side? And that is what we are checking. If we check it and the left hand side is equal to the right hand side, it means that it is what? True. And now let's go. Okay, recall from this equation, let's just say equation 1. Equation 1. From this equation, you can realize, you can agree with me that from here to here, there is a name we call it, is this. So I can replace it. I can say recall that 1 plus 2 plus 3 plus K is equal to K into K plus 1 all over what? 2. Okay. From this place, we can now continue here. So K plus 1 equal to what? So now we replace this one from here. So what do we have? The left hand side, we are solving for what? Left hand side of the equation 1. So we will replace this one from here, which is now K into K plus 1 all over 2 plus what do we have here? K plus what? 1. So let's just assume that this is like 1. Now let's go here. What do we do here? Expand this. We have K squared plus what? K all over what? 2 plus K plus what? 1 all over 1. What is our LCM? LCM is 2. 2 go to this, which is now K squared plus what? K plus 2 go to this, which is now 2 into K plus 1. Close it. Finally, what do we have? We have K squared plus K, 2 times K plus 2K, 2 times 1 plus what? 2, all over what? 2. Now, what do we have finally? We have collection of like terms. We have K squared plus 3K plus 2, all over what? 2. And that is it. Call it equation star. Equation star star. So we are going to check after solving this in the equation star, will it give us the what? The right hand side. Let's expand that right hand side and see what we get. Okay. From this place, our right hand side is 4RHS. So which right hand side. So which we have K plus 1 into. Okay, this is K into what? Into K plus 1 plus 1, which is what? 2. Close it. All over what? 2. Now let's expand this. We have this thing as K times K, which is what? K square. K times 2, we have it as 2K. 2K. 1 times K plus K. 1 times 2 plus what? 2. All over what? 2. Now collection of like term. This to this, we have this as K square plus 3K plus what? 2. All over what? 2. Equation triangle. We have equation triangle. Now we need to compare. We need to compare if P of K plus 1 is true. By comparing equation triangle and equation star, compare equation star with equation triangle, double triangle. Now equation star says k square plus 3k plus 2 all over what 2. Is it equal to equation triangle, which is a k square plus 3k plus 2 all over 2? Hence, it is true. Hence, P of k plus 1 is 2. Therefore, we have that P of 1, P of k and P of k plus 1 are 2. And that is how to solve mathematical induction. Thanks and God bless you. Remember to subscribe to my YouTube channel, Prismatic Online Class. Thanks.